Hey, this is Christy Combs, your practical partner, and I'm here with another instructional newsletter. I can't tell you how excited I am about a class we have right here at James Clemens, the Aerospace Engineering class. Living here in the heart of the aerospace industry, our students are so lucky to have this opportunity, participating in a Project Lead the Way class that also partners with NASA and begins to establish internships. I want to tell you a little bit about what Mr. Frederick's class has done this past week. So at the beginning of the course, Mr. Frederick teaches the physics of flight. Once the students learn the physics of flight, design properties are introduced. How Mr. Frederick allows his students to apply the properties of flight and design is through creating balsamer wood gliders. But don't take my word for it. Let's hear about it from one of the students.
The wing is slightly tapered so the air is able to pass over and under it, and the top would be tapered to a point on the end so that the air is pointed to a direction and it doesn't become a vacuum. So the air passing over it goes faster than the air passing under it, meaning which generates lift. And then with our horizontal stabilizers, they're pointed slightly downwards so that it lifts our nose up, which allows the plane to go straight and fly upwards.
Wow, that's pretty cool, huh? So after they've flown their gliders and they kind of have a better idea about design, then they get to create their own wings. So they got to determine a purpose for their specific aircraft. Are they going to design a wing for a fighter jet or like a passenger plane? Once they do that, they use software supplied to us by NASA. This is the same thing aerospace engineers really use. They design their wing on the software, and then here's the super cool part. They print it out on a 3D printer. Look at this. Isn't that cool? So after they've printed out their wing, then they put it in a wind tunnel simulator, just like this one. They run tests. They collect data, and then they determine if the wing is successful. Here's a student explaining the success of his wing.
My airfoil to be shaped like this because these type of airfoils are symmetrical, so they can be made for like big airplanes, so they're meant to carry really heavy things like passenger airplanes with even double-decker planes.
Guys, do you see what I'm saying? This is the coolest thing ever. It's real world, it's hands-on, and it's working with things we have right here in Huntsville. How awesome! Thanks, Mr. Frederick, for exposing our student to such cool things. That's Christy Combs, your practical partner. I'll be back soon with more instructional news. Bye.